Hey guys, this is Fraser from Thanks for Tutoring. Today we're going to be doing the 6-mark paper 1 question. This is a pretty new one, at least if you're watching the video now. It's from 2022. And it's a functions question. It's actually a graphic one, looking at asymptotes, vertical and horizontal asymptotes, and then using that to solve an inequality. So there's a bit of sort of linking two different areas of the course together. So we're going to be looking at this function over here, 2x minus 1 over x plus 1. It says fx has both a vertical and a horizontal asymptote. We have to write down the equations of these. So we know that the vertical asymptote is when the denominator, so I'll just write that as denom, equals 0, right? Because we can't divide by 0. This leads to all sort of problems. So that means that we want the denominator being equal to 0. So that means that x plus 1 equals 0, which means the equation is x equals minus 1. So there's just going to be a straight line at x equals minus 1. That's the vertical asymptote. Horizontal asymptote, there's a trick to do this, but it's really the only way I know. So essentially, if the degrees of the functions agree, meaning we have in this case, a linear divided by a linear, that means we can just divide the coefficient of the top x by the bottom x. And that's going to be our horizontal asymptote. So that's actually going to be y equals, so the coefficient on the top is 2 and the coefficient on the bottom is 1, right? Because there's that hidden 1 there. So 2 over 1, which is just 2. And if the degree is higher on the top, then we don't have a horizontal asymptote. It basically goes to infinity. And if the degree is larger on the bottom, for example, if we had a linear divided by a quadratic, we would just get that it goes down to 0. It's essentially to do with growth, so they sort of grow either faster or slower than the other one. So we have our two asymptotes, y equals 2 and x equals minus 1. Now it asks us to sketch fx, clearly indicating, this is very important, indicating asymptotes, so we have to say what our asymptotes are, and the position of points of intersection with the axes. So we have to actually write down where they intersect with the axes. So I'm going to do this in a different color. So what do we know? Well, first of all, we know that we have a vertical asymptote at minus 1. That's going to be over here. Actually, I'm going to do a completely different color. That's not too good. What color should we do? Let's go with red. So let's do like a dotted line here, because at minus 1, like this. So that's our vertical asymptote. And then we also have the horizontal asymptote at 2. And because it says clearly indicating, it might just be safer to say y equals 2 and x equals minus 1. So those are our asymptotes. Now points of intersection. So when does it intersect with the x-axis? Well, that's when y is 0. Now when is y 0? That's when 2x minus 1 is 0. When is 2x minus 1? So we need 2x minus 1 equals 0. So 2x equals 1, so x must equal 1/2. So when x equals 1/2, y is 0. So that means that should be about here. So that's at 1/2 0. So it means by indicating. Actually, I'm going to do that in red just to follow what we were doing before, so you don't get confused. 1/2 0. And what about when x is 0? Well, when x is 0, we have 0 minus 1 over 0 plus 1. That's just minus 1. So our intercept is going to be at 0 minus 1, which is down here. 0 minus 1. It's a bit difficult with these sometimes. Obviously it's a bit easier on graph paper just because it's a bit squashed up. Okay, so now we've got this. We know that it has to pass through those points, and we know that it asymptotes. So we know that the graph at this point is going to look something like asymptote goes through an asymptote. It's not a perfect graph, but it gets the shape. And therefore, the general shape of these means that there's going to be another one over here that asymptotes like this, and asymptotes up like that. And I think that should get you full marks, because we've indicated the asymptotes, we've indicated the points of intersection, and we've actually drawn the graph. You make sure it doesn't actually cross. Obviously, it can't cross the line because it's an asymptote. So make sure that it's obvious that it's never going to cross. It's actually going to sort of plateau out a little bit. And the last part is hence solve the inequality. 0 is less than or equal to 2x minus 1 over x plus 1, which is less than, not equal to, less than 2. So if you'll notice, this is actually f of x. So what we're solving is 0 is less than f of x is less than 2. So now we can look over here, and we know that at x equals 1/2, f of x is 0, right? That's what we said at this point. So that means that f of x is greater than 0 when x is greater than 1/2, right? Because it's an increasing function. And we know that there's an asymptote at 2. So that means that f of x is actually never going to be greater than 2 along this interval. So if we imagine sort of going along from this 1/2 like this, it's never going to be greater than 2 because that's the point of the asymptote. That's what it means by definition, that it's never going to, what would be the word, like go over it in a way. So that means that actually our inequality is literally just x is greater than 1/2, right? Because we're trying to think about when is the graph between these two lines. Well, we know that it's 0 at 1/2, and because we only want a greater inequality, that means it has to be greater than 1/2. And when is it ever going to be equal to 2? It's never going to be equal to 2 because it's an asymptote, so it's just going to be greater than 1/2, right? And nowhere else is the graph within this interval, right? Because before it goes down, and then in the negative axis, it's actually above 2 at all points, so it's only this interval. So hopefully that was clear. It's a bit of a difficult question. It's quite long as well, 6 marks. You can see respectively how many marks each part is worth. So yeah, hopefully that was helpful. If you guys want more of this kind of stuff, you know, doing exam questions, getting some prep, getting some tutoring, feel free to head over to Thanks My Tutoring. You can sign up, it's really easy. You can set your own timetable, however frequently you want. Yeah, so feel free to go over there. I'll be making more of these videos. Have a great day and see you soon.